When you're saving lives and every second counts, that's when their time has come. Rescue helicopters. In extreme situations, the helicopter and its team help to save lives.
Without our artificial respiration, the patient would not survive.
Saving lives in the smallest of spaces. The rescue helicopter H-145 is a flying intensive care unit equipped with the latest technology. The helicopter's mechanics place the highest demands on material and equipment.
We have to really concentrate. There are 20 kilometers of cable in here.
After 3 months, a brand new helicopter is ready to go and takes off for the first time. The crew has to function perfectly too. Air rescue personnel receive special training. A constant stream of new training deployments and hundreds of hours in a flight simulator prepare the crews for their often life-threatening missions.
You're hanging there 15 meters up in the air. Mistakes can be deadly. We're on our way.
When the alarm sounds and there's an emergency, man and machine have to function like clockwork. In the Bavarian town of Donauwörth stands a huge helicopter factory. Around 7,000 people work here, building 4 different kinds of helicopters for police, the Air Force, and the Alpine Rescue Service. The rescue helicopter H-145 is also built there. The H-145 has amazing maneuverability. It is 13 meters long, and fully equipped it weighs 2.3 tons. 2 825 horsepower engines drive the main and tail rotor systems. A top speed of 250 kilometers per hour. Cruising altitude 5,500 meters. The price, depending on equipment, up to 8 million euros. This is how the production of the H-145 starts. A computer-operated high-performance cutter slices carbon fiber and glass fiber sheets with millimeter precision. In a complicated process, these materials are combined to create what is technically referred to as carbon composite. This ultralight and very strong material gives the helicopter excellent flight characteristics. 200 employees work on the production of these carbon composite parts. The sticky material is applied to a large mold, layer by layer.
This material is carbon fiber fabric, individual fibers embedded in a resin matrix. Traditionally, aircraft construction used aluminium, but today the trend is going more and more towards using carbon fibers. Carbon is a very light material, and of course the resulting helicopter is also lighter. As a result, it can stay in the air longer.
This steel mold is used to create one of the doors of the H-145. The doors are made completely out of the ultralight glass and carbon fiber material. First, an employee puts the sticky fiber material into the steel mold, the negative of the side door. This first layer of glass fiber is followed by 8 layers of carbon fiber fabric. In order to create the extremely strong carbon composite, the pockets of air have to be removed from between the various layers. Pockets of air would make the material porous and unstable. A silicone cover creates an airtight seal so that a vacuum can be created in the steel mold. Hoses are attached which extract the air under the cover, and also the air between the glass and the carbon fiber layers. After vacuuming, a lid closes off the mold. This is then placed in a special oven, a so-called autoclave. The factory has 5 of these giant autoclaves, and they are in operation 24 hours a day. The largest one has a diameter of 4 meters and is 15 meters long. In the autoclaves, the composite parts are subject to heat and pressure. A standard home pressure cooker works in the same principle and is, in principle, a small autoclave. The 700-kilo steel form with the side door is waiting to be processed. Together with other parts, it is now being driven into the huge pressure chamber. An employee connects the air pressure hoses that take air out of the steel mold. Finally, a giant lid seals off the chamber. Inside the autoclave, there's now a pressure of 7 bar and a temperature of around 180 degrees Celsius. The side door is subject to these conditions for 10 hours, and then the composite part is finished. Since the 1990s, helicopter companies have been using more and more composites instead of light metals, such as aluminum. Carbon is extremely flexible and stable, and above all, very light. This door is just one of the 94,000 carbon composite components that the factory produces every year. Employees remove the piece from the steel mold. The side door is now finished. It is so light you can pick it up with one finger.
You can see how light this carbon door is. An aluminium door would be noticeably heavier. That is the real advantage of composites.
A large part of the H-145 is made of composite materials. So too, for example, the tail boom and the cabin frame.
It is a very large element, and when you consider it only weighs 11 kilos, that is extremely light.
The final helicopter will weigh around 2,300 kilos. That is one of the reasons why the H-145 is so extremely maneuverable and well suited for difficult flying operations. But pilots have to be well trained to handle them. In Bonn-Heingelaar, 1,000 aerial rescue helicopter pilots train special maneuvers with the H-145 every year. Hector Hecht is an experienced pilot with 5,200 hours of flying time under his belt. He, like all other helicopter pilots, has to be recertified twice a year. Also on board, examiner Andreas Schmidt. The test begins. Hecht starts the 1,650 horsepower engines. The destination is a clearing in a forest close by. Here they will simulate picking up a patient. This helicopter can be switched to training mode at any time. That lets the examiner do things like simulate an engine failure. The pilot has to react properly and show that he can fly the helicopter safely. They quickly reach the landing spot, a 30 by 30 meter clearing. The pilot lands the helicopter. There are only a few meters of space between the rotor blades and the trees. The turbulence here is unpredictable. A short stop on the ground. The patient would now be on board. Hecht quickly leaves the danger zone. The helicopter rises at a speed of 5 meters per second. The maneuver was successful. Now back to base. After 45 minutes, Hector Hecht prepares to land. There are 320 tests like this per year solely for the 160 pilots of the ADAC Air Rescue. 1 hour flight time costs around 2,400 euros. In this case, the costs are paid for by the Air Rescue Department of Germany's automobile club, the ADAC. The exam is over. What does the tester have to say?
Naturally, Hector has passed his check flight by successfully completing this rescue and emergency mission.
Back to Bavaria. The helicopter factory in Donauwörth manufactures around 90 H-145 helicopters per year. The rotor blades are produced here as well. Just under 50 employees produce around 400 blades per year by hand. The four blades of the main rotor revolve at more than 380 RPMs and have to withstand tensile forces of up to 20 tons. A rotor blade has a length of more than 5 meters and weighs around 40 kilos. The blades are made by hand using huge forms. The first layer is fiberglass. Then comes 3 layers of carbon fiber in a resin matrix. The so-called blade root is that part of the blade that is later attached to the rotor head. Extremely strong forces are at work here during flight. That is why the specialists who build them put on 24 individual layers of the carbon fiber material. Here they use especially long strands of glass fiber called roving.
You have to think of a roving as individual threads that lie side by side, covered with resin. They are then extremely strong in the direction of the tensile force. They keep the entire rotor blade right where it's supposed to be. A roving could easily be used to pull a large truck, no question. It is easily strong enough for that.
The inside of the blade is filled with a light, rigid foam core. This half of the rotor blade is now ready for further processing. The steel form is put into a special press. The upper half is already in the form. The two halves are pressed together with a pressure of 200 bar at 135 degrees Celsius. After 11 hours, the process is finished and the carbon rotor blade is ready to go.
Visual inspection looks good. Now we take it over to the crew workstation and quality control will take a closer look at it.
The blade has passed the first optical check. But how does it sound? 2 men carry the 40-kilo blade to a special test bench.
We tap the blade to see whether the erosion protection shell, which you can see here, the light part, has bonded properly with the composite. In the worst case, it could mean that the erosion protection shell detaches from the blade and possibly hits the helicopter, with the corresponding force and resulting damage. If it sounds nice and full, then we're on the safe side.
It took 3 years until Christian Eisenhofer was able to discern the fine differences in sound. However, only those blades are approved for flight operations that have gone through a final computed tomography scan. The CT scanner was originally developed for medical use. It takes numerous X-rays of the rotor blade from a variety of directions and puts these together in a multi-layer model. This enables the experts to track down even the smallest material defect.
We create individual images with a spacing of 25 millimeters, and in the critical area we have volume renderings, which means around 400 images with a spacing of 0.625 millimeters.
The blade root is particularly critical since it is subject to extreme centrifugal forces. During flight, there's a tensile load of up to 20 tons. Radiologist Rudolf Kopp is looking for so-called delaminations. Delamination happens when the glass fiber and carbon fiber layers in the blade start to come apart. A dangerous thing when you are flying.
That would mean that the rovings become loose. The pilot gets an imbalance in the machine because the blade root is softening. And he notices that. The rule for the pilot, an imbalance which is noticeable in the stick means land.
A further critical area is right before the root of the blade.
It is subject to constant impact pressure. There is a danger that the fibers might tear. Here you can see a small bump. We'll measure that one. It's 1.3 millimeters. For me, that means I have to make a quality report and show this to the construction and statics people.
This blade goes through another quality control. If it does not meet the high demands, it will be scrapped. Later, the blades are firmly fixed to the rotor hub. The main rotor, with a diameter of 11 meters, spins at a speed of up to 383 RPMs. Extremely strong centrifugal forces tug at the star-shaped component. The rotor hubs are created in the metal cutting department. High-tech milling machines shape the forged titanium blanks with an accuracy of 1/1000th of a millimeter.
After we are halfway through the processing, we let the hub rest. The processing causes tensions to build up in the blank, and we give them time to dissipate. If we did not allow the material to rest, then the tensions would only be released after we're finished, and we would not be able to stay in accordance with the tolerances.
The hub has to be absolutely round. That is why it is given up to 10 days of rest. The 15-kilogram hub is finished. It's worth 25,000 euros. For the blades of the main rotor, the next stop is the rotor test bench. Here, the blades are brought into balance.
When the blades have been set up, we let them run for about 15 to 20 minutes, and then we look at the data. Up there you can see that red thing on top. That is the telemetry, which transmits the data to the control room. We also have a camera here, and the camera measures the distance between the rotor blades during the flight.
From the safety of the control room, the technicians increase the speed. The telemetry system sends vast amounts of test run data to the control room. The technicians use that data to find, and if needed, correct any weak points on this set of rotor blades. Jürgen Lulay will now balance the blades. Similar to a car tire, achieving the perfect balance eliminates dangerous vibrations.
Here on the rotor blade, these two parts are called trembliers. Bending these two trembliers influences the aerodynamic characteristics of the blade.
Depending on how the engineer bends these two pieces of metal, the rotor will tilt during flight. This aerodynamic balancing is extremely important, so that the helicopter can even start. Jürgen Lulay goes up in the lifter to reach the balancing chamber of the rotor blade. This is another place where he can change the center of gravity.
Now you can see the springs. The purpose of these springs is to push the trim weights to the front. And then you see these weights. You can shift these weights to the left or the right to influence the dynamic behavior of the blade. We have the blade's center gravity here and the blade depth. And when I exchange these weights, then it tilts to the front or the back. And there, 45 or 90 grams is enough to do it.
These four blades are now perfectly balanced. And you can hear it. The more precisely the blades follow one another, the quieter the propeller. In the Bavarian town of Bad Tölz, there's a helicopter that can take off without any rotor blades. Since 2008, the Bavarian Alpine Rescue Team has a simulation facility here where the rescue professionals practice dealing with various extreme situations. In the high-tech training hall with 18-meter-high ceilings, there is a practice helicopter attached to a complex system of rails and wires. The system is completely independent from the weather outside. Here, teams can fly 24 hours a day without using a single liter of fuel. Every year, around 1,000 active aerial rescue teams come here to practice dealing with emergencies. The training conditions in the hall are incredibly realistic. The helicopter has a number of special characteristics. A wind machine imitates the deafening sound and the enormous wind of the helicopter's main rotor. Special stroboscopes simulate the sun shining through the rotor blades. The examiner Karl Strehler is going to look at 3 rescuers with a dog. The specialists are about to take an important test. Every rescue worker has to be recertified once a year.
Good to see you here for the annual certification. You have everything with you, right? Then let's get started with the training.
The tension mounts. The winch operator gives final instructions. Then the test starts for the rescuer Thomas Tichtel and his colleague Till Godelius.
This is just a practice run, but I'm nervous even here in the simulator. You're hanging from 15 meters up in the air. A mistake can be fatal.
Today's scenario, this mountaineer is stuck on a rock wall. She has a severe arm injury and cannot free herself. The rescue team gets into the helicopter. The pilot takes off and positions the simulator 15 meters over the casualty. The first Alpine rescuer is let down and uses a safe place to get the rescue bag ready. Rescuer number 2 also goes down. He has to rescue the casualty and get her safely off the wall. The rope of the winch, on which he is hanging, can be let down a full 90 meters.
How are you doing? Everything okay?
Yes.
In a situation like this, it is difficult for the rescuer to evaluate the severity of the mountaineer's injuries. Quickly but carefully, he puts on the safety belt. With a hand signal, Till Godelius tells his colleague to start the winch. First, the injured person is brought out of the danger zone. The mountaineer is not yet ready to be transported. For the transport, Thomas Tichtel has prepared the rescue bag with the integrated vacuum mattress.
We have secured her here on the vacuum bed, and now we are pumping air out of the bed itself. The lower part becomes really stiff so that she can lie there completely horizontally. Now she would be secured in here. Close it up and get her ready to be transported by helicopter.
The victim is now securely in the rescue bag. The hook is let down again. And Thomas Tichtel gives the sign to start the winch. The helicopter's rescue winch can lift up to 270 kilos. The Alpine rescue team and the winch operator maneuver the mountaineer into the helicopter. But head first. The first small mistake today. Will they still be recertified?
I saw up there that it was a bit complicated the way you brought her into the helicopter. The best thing is to bring the patient in feet first. So you have your certification and we'll see you again for another test next year.
The 2 Alpine rescuers now have their certification for another year and can continue to save lives in the mountains of Bavaria. The helicopter factory in Donauwörth. In the main component assembly, employees are busy riveting the cabin frame to the helicopter cell. Riveted joints are much more flexible than screws or welded seams. On the roof of the H-145, they're installing a firewall.
The firewall is there to protect the material, because the engines will be installed on the left and the right here. They're very, very high thermal loads, and that stresses the material.
The 2 engines can heat up to 200 degrees Celsius. Not a problem for the firewall, because titanium melts at 1,668 degrees. Next door, 50 employees are putting in electric cables. Depending on the equipment of the H-145, that can take up to 18 days. Several thousand meters of cable go into every helicopter, but the experts in the factory always keep a clear overview.
You can't go out and make a large clump and just throw everything in at once. The roots of the cable bundles must be separated.
Where the cables have to go has been carefully calculated. Every gram at the wrong spot changes the center of gravity and thereby the flight behavior of the rescue helicopter. At the center of the complicated cabling is the main console in the cockpit.
The center console is the base for all the cabling, where all the equipment for the pilot and co-pilot go. This becomes very specific. Which equipment, which displays the pilot has at his disposal, what kind of client it is, and what functions do they need. Are they flying rescue missions, or is it for private use? There are clear differences here.
A monster of a task. Thousands of connectors and connections have to be correctly installed.
We have to really concentrate. There are 20 kilometers of cables in here and quite a few connections. It's important that we don't make any mistakes, otherwise there might be complications during flight. That would of course be bad for the pilot and even life-threatening.
After 3 weeks, this H-145 is completely wired. Here on the roof of the H-145 are 2 shaft turbine engines that drive the 2 rotors. Even if one of the 825 horsepower engines failed in mid-flight, the helicopter would have no trouble continuing on its way. Today, in the final assembly, the engines are going to be mounted onto the helicopter. Despite the robust technology, the employees have to be very careful. Slowly and carefully, the crane lifts the 130-kilogram engine into the air. The shaft turbine is specially designed for the propulsion of helicopters. This type of engine was first used in 1977. With pinpoint precision, the mechanics put the second engine beside the firewall.
As you can see, it's a pretty tight fit because the firewall is in the way, and there are of course also cables and pipes. The crane operator has to work slowly and with great concentration to get the engine into position. And we have to see that we connect everything properly, that we don't damage anything, that the engines function, run well.
The helicopter now has 1,650 horsepower mounted on its back. Once both engines are hooked up, a drive shaft connects them to the rotor hub. A heat-resistant covering made of composite material seals off the engine. The H-145 is now on the home stretch. The tail boom is bolted onto the helicopter. The tail rotor has a diameter of 115 centimeters and for safety reasons is completely encased. The interior. The last parts are being put in. Employees are installing 11 of these interior wall parts. Then all the cables will be covered up. And this is what the basic configuration of the H-145 looks like.
Specific configurations for this helicopter are the fittings for narrow seats that we see here, the black fittings from the front through to the back. The equipment board will be installed on them, where the medical technology is kept and secured. Up here, there are fixtures for the ceiling rails where you can hang infusions. The patient will lie down here on this side or on the other side. That is the basic configuration for this helicopter.
It takes 10 days for the men to put in the interior paneling and to fit it to the customer's needs. After just over 4 months, a brand new rescue helicopter worth 8 million euros leaves the hangar. It is about to go on its first flight. With a heli-lifter, an employee brings the helicopter to its start position on the factory airfield. All the helicopters that are built in Donauwörth go for their maiden flight on the 170,000 square meter large factory testing ground. Test pilot Herbert Kistler and flight test engineer Mario Hammers take the new H-145 off the ground for the first time. An optical check is followed by a so-called ground run. Test pilot Kistler starts both turbines, and the rotor starts to turn. Without leaving the ground, all the instruments are checked while the engines are running. The values shown on the displays have to meet very exact norms. Only once the helicopter has proven that it is functioning perfectly are the pilots allowed to take off. The employees of the helicopter factory have done their utmost for this moment. There is now a new H-145 rescue helicopter flying through the air. The test pilot flies a set protocol with mandatory maneuvers: hover, forwards, sideways, rotation around the vertical axis, and with the nose down. During these maneuvers, test flight engineer Mario Hammers compares the data shown by the displays with the norm values in the protocol. Later on rescue missions, the helicopter will have to start, fly, and land under very difficult conditions. This machine gets top grades. The helicopter is now officially allowed to fly in public airspace. It cannot, however, take part in any rescue missions yet. The entire medical technical equipment still needs to be installed. The Simulation Center in Bad Tölz. It's the moment of truth for alpine rescuer Martin Klutz and his 4-year-old search dog Kanda. They are both avalanche rescue specialists and are about to practice being dropped down.
The important thing about this training is that we practice getting in and out when we're up in the air.
The wind, the weather, the noises, not knowing what a helicopter is, that is something really challenging for a dog when it has to work under completely different conditions than it does down on the ground. That's what we're training.
The mission begins. Slowly, the helicopter rises. Helicopters are not unknown for Kanda, but she remains skeptical. The background noise of the simulator is realistic and as loud as a real helicopter. For the dog with its sensitive ears, the noise is stressful. Examiner Karl Strehle monitors the mission from down below and checks to make sure that all of the processes are right. The pilot steers the cockpit to the right position under the hall roof.
We are now 14 meters above the floor of the hall, and in just a moment we will reach the position where we get out.
Even if it is only training, it is still dangerous. Getting out of the helicopter is a perilous moment and requires a lot of concentration, especially if there is an animal involved. The rescue team is now hanging 14 meters above the floor of the hall. The winch operator lowers the two into the depths. After an avalanche, Martin Klutz and Kanda would be lowered from a helicopter to look for survivors. A situation in which seconds can make a difference for those buried under the snow. Today, the rescue team only has very brief contact with the floor. Then the winch operator pulls the two up again. Getting back on board also worked well. Dog and human are back in the helicopter.
The dog is trembling slightly, but is taking it quite well, a bit afraid to begin with. Ooh, I have to go out again. Though it worked out quite well, and in the air, hanging on the winch, everything was fairly relaxed.
The pilot lands the machine. After 10 minutes, Kanda and Martin Klutz are done. The K9 human rescue team has been recertified.
Thanks, we'll see you again next year.
In Donauwörth, a brand new H-145 lifted off from the ground for the first time and was thoroughly tested. The machine has been approved for flight operations and will now be fitted with life-saving medical equipment. Right now, there is nothing inside the machine other than the technical instruments needed to fly it and 2 seats for the pilots. 450 kilometers away, in St. Augustin, an H-145 is turned into a real rescue helicopter. Here they are specialized in installing the necessary interior fittings and medical equipment. First of all, everything except for the electrics is taken out again. The team exposes all of the interfaces so that they can install the specialized technology. In the next few weeks, new analog and digital radio communication systems are installed. A weather radar, new software applications in the cockpit and searchlights. The lock for the rear door is exchanged and now can be opened and closed with one hand. All of the interior fittings have to be very robust, and that comes at a price.
Die Besonderheit an diesem Equipment ist, dass es sehr robust sein muss.
Equipment like this has to be able to take a lot of punishment. Take the surfaces of these seats, for example. You have to be able to get blood or disinfectant off them. In aviation, getting something approved for production, no matter what it is expensive. So a seat like this can cost between 5,000 to 8,000 euros.
And the stretcher, at a price of 30,000 euros, is not exactly a bargain either. For the stretcher, the team installs a special rail system with quick release locks.
It makes it easier to get the patient in. You arrive here with a stretcher and it slides into this groove. Then you just need to push it into the rails.
After the stretcher comes the center cabinet, where medication and medical equipment will be kept. Then the team puts in the seats for the doctor and the assistant. They can easily be put in and taken out thanks to the quick-release fasteners. However, their position inside the helicopter is precisely defined.
They
all have a specific mass in a specific position. The problem is that moving them around moves the helicopter's center of gravity. You can slide the seats back and forth on the rails. Also very good, very important and useful, they can swivel so that you have optimal access to the patient. Also important is that the doctor or the paramedic can access the oxygen supply.
400,000 euros. That is how much the installation of the medical equipment costs. After 50 days, the helicopter is now a real rescue helicopter and can fly its first mission. Rescue operations like the DRF, the German Air Rescue Squad, fly more than 1,000 times a year from the emergency hospital in Berlin. This helicopter rescue team is getting ready for its shift. The team consists of a pilot, a paramedic, and a doctor. The high-tech helicopter has been in operation since 2016.
This is an intensive care respirator. Then we have 4 perfusers. Those are these syringe drivers here that we use when medication has to be given continuously, just like in an intensive care unit. Then, of course, we have lots of oxygen on board. Very important. They are kept in the back of the machine. Here we have a compact monitor with a Bluetooth interface, which means that the monitor itself can be decoupled. We can carry it with us without any cables attached. Basically, we have an entire mini intensive care unit.
Pilot Thomas Reimer learned how to fly in the military and has been with the Air Rescue Squad since 1992. In his cockpit, he gets all the important information.
In this pop-up, we see information that the control center sends us, possibly about the accident scene, mission scenarios, a trapped person or someone has fallen out of a window or something. That is the kind of information that might appear on the screen here, things that we can evaluate while we're flying so we know what to expect, possibly also information about the landing site. The site is on a sports field, by the road, has been prepared, not prepared, police are there. Those are all pieces of information that the control center sends us right into the cockpit.
The coordination center of the emergency hospital in Berlin receives an emergency call.
The patient has 4 syringe pumps? Okay, and you still have to intubate? Yeah, okay. And would you say it's a myocardial infarction, or how would you describe it? Good, we're on our way. We'll be with you in about 30 minutes. Okay, thanks. Bye. We've got a call from a hospital outside of Berlin, in Grannensee. One of their patients has to be transferred to the cardiac center here in Berlin. She's experiencing a so-called cardiogenic shock. You have to think of it this way. The patient has a heart that is no longer pumping. It can no longer support life, so she will have to be transferred to the cardiac center so that they can attach her to a heart support system.
The patient's condition is life-threatening. They have to move fast. The H-145 is already waiting on the roof of the hospital. Only a few moments after the emergency call comes in, the helicopter is already airborne. The DRF rescue team is usually called into action when it is a question of life or death. Bonn-Hangela. Annually, 1,000 pilots come here to be trained specifically for situations such as these. In these gigantic helicopter simulators, pilots train to handle real emergencies. Every possible scenario can be staged in these 12 million euro magic spheres.
We have a horizontal view of 240 degrees. Vertical 180 degrees. In the database, we have the entire globe at our fingertips. Offshore operations, daytime operations, night vision, the entire range.
Flight trainer Andreas Schmidt enters one of the simulators together with rescue pilot Hector Hecht. Hecht already has 5,200 hours of flight time under his belt, but constant further training is a part of his job. The men get into the cockpit of the simulator. Trainer Schmidt has chosen a massive pileup on the motorway. The simulator is ready to go. Time for the utmost concentration.
Okay, then let's get this thing going.
The maneuver starts at Koblenz Airport. The high-tech simulator very realistically imitates the movements of the H-145 helicopter. The pilot's senses take in a perfect illusion. The internal LED projector shows landscapes and buildings that have been generated from real aerial photographs. They quickly arrive at the scene of the accident.
We're getting to that area again where we can't leave the valley, so we'll land.
The accident site is under a large bridge and is surrounded by high-voltage power lines. That means the utmost vigilance for the crew. The simulator moves down. That means descent. Slowly, the helicopter approaches the landing spot on a field. Now the pilot is paying special attention to the first responders on the ground. No one is allowed in the landing zone. Done. But pilots are often needed after the landing too, especially if there are many injured people.
Especially with the situation we've just simulated, it may well be necessary for us to give a helping hand. Whether it's carrying equipment, supporting the doctor, that kind of thing can happen.
The flight simulators in Bonn are so realistic that the practice sessions in them count as real flight time for the pilot. The DRF Air Rescue Team is on its way to an emergency. A patient is in mortal danger. Dr. Janssen and his team have to transfer her from a small hospital outside of Berlin to a cardiac center.
Yeah, there's a patient. She's experienced cardiogenic shock and she has not yet been intubated. But for the flight, he wants to respirate her through intubation.
The helicopter cannot land at the hospital. They pick up the patient at a nearby heliport. The woman's heart is beating weakly. She is in an artificial coma and has to be flown to the cardiac center to be operated on as quickly as possible. Together, the 4 rescue workers load the patient into the helicopter as free of jolts as possible.
Yep, everything is okay. Can we start? You bet.
The pilot takes off. It's 65 kilometers to the cardiac center in Berlin. The helicopter travels at up to 250 kilometers an hour and doesn't have to worry about traffic jams. It is the fastest way to get the patient to the cardiac clinic. She is being respirated during the flight. If they did not do that, she would die. The doctor and the paramedic keep a watchful eye on her the whole time.
Pressure's good? Medium pressure's good?
50, medium pressure 70.
Perfusers are all running.
Yes.
So the patient is what we call analgesic sedated. She's getting medication to block the pain, and so that she's not conscious, anesthesia medication. Without our medication and without our respirator, the patient would not survive. That's how sick she is.
In less than 30 minutes, the rescue team lands in the roof of the cardiac center. The patient can now have her life-saving operation. This rescue helicopter flies well over 1,000 missions per year. The helicopter and its team have just saved 1 life and are already on their way to their next mission. The H-145 is a high-tech rescue helicopter. From the first assembly step to the finished helicopter, it takes 4 months. The Flying Intensive Care Unit costs 8 million euros. The first responders on board risk their own lives to help people in trouble. The pilots go through complex training in order to be able to fly one of the most maneuverable rescue helicopters in the world. More than 100,000 life-saving missions are flown in Germany every year. When the alarm sounds, they take off with the mission of saving human lives.